our quality of life. In this webinar, the following fundamental engineering principles related to the design, construction, and operation of sanitary landfills will be presented. Slope stability and erosion control, stabilization and design of gravel access roads, surface and subsurface drainage design, selection and design of landfill liners, a system of clay liners and/or geosynthetic membranes used to contain leachate and prevent contamination flow to groundwater. Alternatives to soil cover. Before we begin, a few reminders. Questions will be entertained during the Q&A section. Use the chat box to send your comments or questions. Presentation slides can be downloaded on the handouts portion. Feedback form and e-certificate request link will be provided right after the session. You may reach us through the following channels and contact information. Carmela Marie Ringad Olikino is a Technical Business Development Engineer for Geosynthetics at Macaferi, Philippines. She obtained her master's degree with a major in Geotechnical Engineering at the De La Salle University and her bachelor's degree in Civil Engineering at the University of the East Caloocan. Carlos Javier Isip is a Technical Business Development Engineer for Erosion Control at Macaferi, Philippines. He obtained his bachelor's degree in Agricultural and Biosystems Engineering from the University of the Philippines, Los Baños, where he specialized in agrometeorology, biostructures, and environment engineering. We are now ready to proceed with our first speaker. Please welcome Engineer Carmela Marie Ringad Olikino.
Hello, good morning everyone. So welcome to our webinar entitled The Innovation on Sanitary Landfill Design. Again, I am Carmela Mariling at Olikino and I am the Technical Business Development Engineer for Geosynthetics. And this presentation is in collaboration with my colleague, Carlos Xavier Isip, and he's the Technical Business Development Engineer for since a sanitary landfill will be constructed by using purely earth materials or purely soil, of course, it needs to have a sloping angle because if you are going to construct it at a vertical manner, it will fail. There will be a global instability. That is why we construct our sanitary landfill, again, using a sloping cross-section. The next part of the construction of a sanitary landfill is the stormwater drainage. The stormwater drainage, it is usually placed or constructed on the perimeter of your sanitary landfill. The purpose of this stormwater drainage is for, of course, to allow stormwater to flow in it because we don't want our stormwater and our leachate. Leachate is the water or the wastewater, it is the water that is produced by the garbage. So we don't want it to be mixed up with our stormwater. Hence, we would like to have an avenue where our stormwater will pass through. Next is the liner facility. In the liner facility, obviously, since like what I have mentioned a while ago, our waste, it produces leachate. Leachate is the water extracted from the waste, and we don't want those leachate to be to penetrate our natural soil. That is why, because we don't want our natural soil to be contaminated. That is why one of the most important areas of construction in sanitary landfill is a liner facility. A liner facility, it is an impermeable layer in your sanitary landfill in which that liner facility impedes the flow of the leachate. So basically, your natural soil will be protected. Next is the leachate facility, of course. If you don't want your leachate to pass through your natural soil, of course, you need to have an avenue where your leachate can flow through. That is why we do have a leachate facility or the pipes, wherein in those pipes, it is where your leachate will flow. Next is the gas vents. This gas vents actually is the ones that allows your methane gases, or it allows the collection of methane gases. We all know that waste, it also produces methane gas, and methane gas, once it is not collected properly, it is inflammable. And if it is inflammable, of course, it can cause risk. It can cause fire. So we would like to have a gas vents facility for us to have a proper collection of those methane gases. Next is access roads. Of course, like what I have mentioned a while ago, our sanitary landfill is usually constructed in an isolated area. That is why we would like to have an access road. Because if it is constructed in an isolated area, there is a tendency that there's still no access in that area. That is why one of the considerations on the construction of sanitary landfill is for us to have a proper access road, because basically in the access road, it is where your garbage trucks or dump trucks will pass through. And then the last area of construction that I will be discussing in here is the landfill cover. So what is a landfill cover? In every end of operating days this is on the operation side of the sanitary landfill. The previous areas of construction is more on the construction side, but this one is for the operation side. Once we have ended the operation of a landfill on a day, it is recommended to put a landfill cover or a soil cover for the prevention of odor, to allow animal control, of course, odor control and erosion control. So basically, this is also part of the operations in which every end of an operating day, you need to put a soil cover with a minimum thickness, in which I will be elaborating it later on. So right now, I will be discussing with you the different design considerations on landfill. I have provided you with a brief introduction on the different areas of construction of sanitary landfill. Right now, I would like to dig deeper on that design consideration, and at the same time, in that area of construction, what technology can we use, or what technology can we innovate for us to have a faster, to have a more efficient, and to have a cheaper construction. So these are what I have mentioned a while ago: the slope, the stormwater drainage, the liner facility, the leachate facility, the gas vents, access roads, and landfill cover. Let me start off with what are the technologies or the innovations that we could incorporate in the construction in the sloping area of our sanitary landfill. So this again is the highlighted area wherein I would like to mention it again, our sanitary landfill is always constructed in a sloping condition because if you would construct it on a vertical manner, there is a instability of the soil. So typically, we have a factor of safety, at least to have, we do need to have a factor of safety of greater than 1.2 for us to say that the slope in our sanitary landfill is safe. But as you can see in here, the typical slope inclination of the slope in a sanitary landfill ranges from 18 to 30 degrees. So again, if you are going to construct a landfill in a sloping manner, it should be in a range of 18 to 30 degrees, 30-degree angle from the horizontal. So right now, this is how, right now, we would like to propose to you, what if we could allow our slope to be steeper? Instead of having a maximum of 30 degrees, what if we allow the construction of the sanitary landfill in a steeper slope? This is how it looks like actually. It is called a reinforced slope. So as you can see in here, this on the left side, the one that is highlighted, this is a typical reinforced soil slope. In this reinforced soil slope, what I would like what we would like to innovate is that instead of constructing your sanitary landfill up until a maximum angle of 30 degrees, why not we incorporate a reinforced soil slope for us to be able to construct our sanitary landfill in a steeper angle? This reinforced soil slope can have an angle of until 70 degrees from the horizontal. So actually, what's in it for us if we are going to construct our sanitary landfill in a steeper slope? So actually, what's in it for us? I have provided here a quick calculation. Imagine having or constructing a sanitary landfill at a 10-meter depth. So I have put in here a side-by-side comparison, or actually a side-by-side image or drawing of a landfill that is constructed in a 30-degree angle and a landfill constructed using a reinforced soil slope having a maximum angle of 70 degrees. And if we are going to have both slopes to have a vertical height of 10 meters, as you can see in here, this highlighted area will be an additional area for us to dispose our waste. Why? Because instead of having um, a more gentle slope of 30 degrees, what happens is that you allow your slope to be steeper. Hence, in this area wherein you have steepened your slope, this is an area where again you can dispose more waste. So basically, if we're going to have a 100 linear meter on all sides of the sanitary landfill, we will be having at least an additional volume of 24,400 cubic meter of waste. So, if we have already disposed an additional volume of 24,400 cubic meters, meaning we will be extending the lifespan of our sanitary landfill. So basically, if example, it is constructed to have a lifespan of 1 year, because you have constructed it at a steeper angle or a steeper slope, what will happen is that your sanitary landfill will continue to operate up until 1 year and 10 months because you have steepened the slope. Actually, this is how a reinforced soil slope looks like. But take note that this is not a reinforced soil slope in a sanitary landfill. I just would like to show you how a reinforced soil slope looks like. This is from a soil bag filled with soil, and then the geogrids will be wrapped around this soil slope. So this is a close-up look of a reinforced soil slope. Actually, other than the reinforced soil slope, other than it being able to be constructed in a steeper angle, another advantage of using reinforced soil slope as a means to construct our sanitary landfill is that on the expansion of our sanitary landfill. What do I mean by that? Because there are times when we're in, if we are already finished with the, if we're already finished with the uh, first landfill. So we have already filled the landfill, the first landfill. What happens is that we will cover it with soil so that it will be a flat area. And then what we will do is that we will find another area for us to construct our sanitary landfill. So what happens is this is an area of sanitary landfill and it is already finished, it is already full, and then I will go to another area to construct my second sanitary landfill. The purpose or one of the advantages of using this reinforced soil slope as a means of construction of your sanitary landfill is that instead of finding another area for your sanitary landfill, what you can do is that you can utilize the space that you had on your previous sanitary landfill and you can just construct your sanitary landfill vertically. So if we have already a finished area here, you can just construct your sanitary landfill vertically by using a what? Reinforced soil embankment. Now, reinforced soil embankment, you just need to construct reinforced soil embankment on the perimeter of the existing uh, landfill, and then you already have your second landfill. And again, it will allow you to save space. Especially, there are some municipalities wherein I believe there are some municipalities that they don't have that much space to construct again another sanitary landfill. So why not construct vertically, expand it vertically? So instead of expanding it horizontally, you can expand it vertically. So this is actually how it looks like. So on your natural ground, you will be constructing a reinforced soil embankment on the perimeter of your land, and it will already serve as your sanitary landfill. And the third advantage of using reinforced soil slope is that in the Philippines, we usually construct or we typically construct our sanitary landfill in a manner of we will dig down we will dig down on a natural ground, and that area, that excavated area will already serve as our sanitary landfill. Actually, um, what we would like to suggest and to innovate is that instead of working downwards, why not we work upwards? Instead of digging down or excavating that natural slope, if this is your natural slope, if this is your natural soil, you will dig down for you to have a sanitary landfill. So what we would like to innovate is that instead of digging down or excavating, why not we construct our sanitary landfill above the natural soil, and then we'll just put a reinforced soil embankment on the perimeter of that natural soil. So actually, what is the comparison of instead of excavating downwards, we just need to backfill and put a reinforced soil embankment on the perimeter. It is more cost effective. It will provide us with a faster construction time. It will actually have a lower carbon footprint, and of course, it is more aesthetically beautiful. I will be explaining to you later why is it more aesthetically beautiful. So as you can see actually in here, on the left side of this reinforced soil embankment and on the right side of this soil reinforced embankment, you can see that there is a green area. Why? Because reinforced soil embankment promotes vegetation. So in time, after some time that you have already finished constructing your reinforced soil embankment, vegetation will thrive. So actually, it will look like this. It will look like this. So imagine if you have constructed your sanitary landfill above your natural ground and you have used a reinforced soil embankment to construct your sanitary landfill, and you have constructed it on the perimeter of your natural ground. In time, as you can see, vegetation will thrive. And as you can see, it is aesthetically beautiful. It looks like they have a man-made mountain in that area. And it doesn't look like a landfill. It doesn't look like waste are being dumped there. Because it is, again, aesthetically beautiful. So again, this is how it looks like. So this is how a reinforced soil embankment looks like on during construction phase. This is on the inside of that reinforced soil embankment. Yeah, this is how it looks like. Yeah. So, on summary on the area of slope, so the use of reinforced soil slope promotes this advantages. So it increases the capacity of the landfill for almost 10 months. It also promotes vertical expansion. It also provides low excavation. Also, it is aesthetically beautiful. And of course, basically, if we use reinforced soil embankment, we can allow our sanitary landfill to be far from the water table. So because there are times when on the middle of our digging down in our sanitary landfill, we have already reached the water table. So at least when we construct our sanitary landfill on a vertically or upward, we could prevent or we could allow ourselves in the construction of our sanitary landfill to be far from the water table. So the next area of construction is stormwater drainage. So again, I have mentioned a while ago that stormwater drainage, it is where your rainfall or your rainwater will flow. So again, it is constructed on the perimeter of your sanitary landfill. And usually, our stormwater drainage is constructed using open channels. So this is how it looks like. And open channels, it is usually constructed using earth canals, meaning they will just excavate. They will just excavate a trapezoidal shape on that portion, and then it will already serve as their earth canal, right, or their open channel. But sometimes when we do have a presence of a smooth soil, what happens is that when there is a rainfall, of course our earth canal is constructed at a minimal slope. So if there is a rainfall, what happens is that there will be a fast flow rate of our open channel, or of our rainfall. So that is why some of the some of our open channel needs to have a rougher surface for the rainfall to flow in a slower manner. That is why we would like to address the issue of that open channel by innovating or incorporating the technology of having a rougher surface. The first one is the use of matrices. Matrices, it is actually rocks that is consolidated or it is compacted in a wire mesh, and then you will put it on the surface of your open channel. Of course, as you can see there, it is a rock. So if it is a rock, once water will flow there will be a presence of slowing down of the flow of the water. So this is how it looks like. The next one is the use of erosion mat, reinforced erosion mat. Our reinforced erosion mat has the same ability like the matrices, in which it allows the flow of the water to be slower than the usual flow rate. So, but it, of course, as you can see there, it is thinner than our matrix is. So actually, this is how it looks like on the installation. So I'm just showing you the construction of putting reinforced erosion mat on open channels. And actually, this reinforced erosion mats, it promotes vegetation as well. So in time, after finishing the construction, if the soil if the soil of your open channel has the ability to produce vegetation, in time what will happen is that this erosion mat will be less visible, and it will be covered with vegetation. So this is how it looks like when it is already covered with vegetation. In time, it will promote vegetation. Yeah, so this is how it looks like. And actually, as you can see in there, that sloping area on the left side, it has a reinforced erosion mat on the construction. And then after some time, as you can see, you cannot visibly see, or it is not already seen on the area, but because erosion mat promotes vegetation, what will happen is that on our open channel, the permanent surface of our open channel will be vegetation. And of course, vegetation, it will also allow your water to flow in a slower manner than the usual. We also have a software actually to be able to calculate the safety of our open channel using different surfaces. If you will be installing different surfaces. So we could also offer that. So actually, the use of alternative material for stormwater drainage has it is also supported by design calculations. Also, it has huge savings compared to reinforced. If we will not be using earth canals, we can use reinforced. But of course, installing surface liners on our open channel is cheaper compared to using reinforced concrete. Of course, using erosion mat, it promotes the vegetation. Also, the design life of this will be more than 50 years. The next area of construction is the liner facility. Again, I have explained to you that this liner will impede the flow of the wastewater or the leachate. So again, the leachate is the water that is being extracted from the waste or the garbage. And we don't want it to be contaminated, we don't want it to contaminate our natural soil. That is why we need to have an impermeable layer of, we do need to have an impermeable layer in our sanitary landfill to impede the flow of that leachate. So this is how actually typical liner looks like. But on the typical design or the conventional design, it is recommended to have a clay layer and then put an HDPE liner above the clay layer. We know that clay, it is impermeable once it is compacted. It will have an impermeable condition. So basically, in the typical or in the conventional design, it is recommended to have at least a 0.6 meter of clay having a coefficient of permeability of less than 1 times 10 raised to negative 9 meters per second. Of course, the lesser the coefficient of permeability or the smaller the coefficient of permeability, the more impermeable your layer is. So again, it is recommended to have a 0.6 meter of clay plus another layer of an HDPE liner, which is also an impermeable layer. So that is the recommendation for the liner facility. But what we could do is that instead of using clay, which is 0.6 meters, why not we incorporate another solution, which is the use of geosynthetic clay liner? So what is a geosynthetic clay liner? Geosynthetic clay liner is a sandwich of two geotextile from above and below of two geotextile, and there is a layer of bentonite clay on the middle. So again, it is a sandwich where in the sandwich are the two geotextile and the spread is the bentonite clay. So instead of using a 0.6 meter clay having this permeability 1 times 10 raised to negative 9, why not use this thinner geosynthetic clay liner? So again, what's in it for us? What will happen is that you can lessen the thickness of your sanitary landfill. That 0.6 layer, 0.6 meter of clay can be lessened to a, let's say, lesser than 1 centimeter of geosynthetic clay liner. And what will happen is that the savings that you had on lessening the thickness of your clay will be an additional volume of waste that can be disposed on our sanitary landfill. And again, of course, it is more beneficial to be able to extend the lifespan of our sanitary landfill. Why? Because of course we will be able to save space and to save the cost. Of course, again, we will be allowing our sanitary landfill to have a longer life, longer span life. So because we have we have lessened the thickness of our system of our liner. So this is how it looks like. We will, on the natural ground, we will be putting our geosynthetic clay liner instead of a 0.6 meter of clay. And then we will be putting, above it, we will be putting a geomembrane or an HDPE liner. And take note, our geosynthetic clay liner, it has a coefficient of permeability of 1.5 times 10 raised to negative 11. And like what I have mentioned a while ago, the lesser the coefficient of permeability or the smaller the coefficient of permeability, the more impermeable your layer is. The only requirement is to have a coefficient of permeability of 1 times 10 raised to negative 9. But in our geosynthetic clay liner, we do have 1.5 times 10 raised to negative 11. So this is just a close-up look of the layering, GCL or geosynthetic clay liner, and then the HDPE liner. So on actual, this is how a GCL looks like. On the natural ground, you need to install your geosynthetic clay liner. And after installing your geosynthetic clay liner, you need to put your HDPE liner. So the next one is the leachate facility. Again, this leachate facility, this is your leachate collection facility. Wherein in this, these are actually pipes. Where in those pipes, it is where your leachate or the water extracted from waste will flow through. What I would like to focus on is on the collection pipe. So on the collection pipe, we do have bottom pipes, we do have inclined pipes, and we do have vertical pipes. Imagine if that is your sanitary landfill and you dispose waste in there. So the water, or the water that is being extracted on the waste, once it is compacted, because you will compact the waste, no? If you have finished the operation of the landfill on that day, you need to compact, and of course, upon the compaction of that waste, there will be an extraction of leachate, and that extracted water, it will flow through these pipes. And these pipes, take note, those are perforated pipes, meaning it has holes in there so that the water will pass through. So this is how it looks like. But of course, you cannot put the waste directly on top of your collection pipe, because you need to put a filter material first. What do I mean by a filter material? You need to put something in there, maybe gravel or sand. You need to put something in there, wherein in that filter material, it is where your waste will be filtered out, and then the leachate will be collected. It will travel, or it will flow there. That is why the filter material is recommended to be either gravel or sand, because we know that gravel and sand, it has voids wherein it allows the flow of water. And as you can see in there, one of the recommendation for the filter materials for bottom pipes is that to have a 50 centimeter thick from the ground of gravel. So basically, if I'm going to go back. If that is your collection pipe, leachate collection pipe, you need to install at least a 50 centimeter high of gravel, gravel in there before putting on waste, for your leachate not to be, of course, contaminated. So as you can see in there, this is a side-by-side comparison. On the upper portion, it is the conventional design, where on your gravel layer, you need to sandwich there your leachate collection pipe. You need to sandwich there because, again, the gravel will serve as your filter material. But what we can do is that instead of using gravel, which is thick, it is recommended to have a thick gravel filter material. Instead of using gravel, why not use another material in which we call it is a drainage geocomposite. So a drainage geocomposite, I'll explain it. So it is again, it is a geocomposite, meaning it is composed of two materials. So it is composed of two geotextile with a drainage material on the middle. And that drainage material is just like your erosion mat, or you just need to put your drainage material and then sandwich it with two geotextile. So what happens is that you just need to put on the end of that drainage geocomposite, you just need to sandwich your leachate collection pipe on that drainage geocomposite, and the geotextile will already serve as a filter material of your waste. So again, what will happen is that because geotextile, it has opening sizes, it allows the flow of water. So your leachate will be collected, will pass through the geotextile, and it will travel in the drainage material on the middle, and then it will travel in the leachate collection pipe. So basically, instead of sandwiching your leachate collection pipe in gravel, you can just sandwich your pipe in a drainage geocomposite. Again, what's in it for us? We can lessen the thickness of our system. Instead of having a thick gravel filter material for leachate, we can just lessen the thickness of that gravel by using drainage geocomposite. Again, we will allow our sanitary landfill to have a longer span life. We can dispose more waste in our sanitary landfill. Next is gas vents. Of course, gas vents, I have explained a while ago, this is like the area where it is a facility where it may collect methane gases for it not to be released in the environment, because this is a flame of methane gases and flammable. Our waste, it produces methane gases, and once it is contaminated, and it doesn't allow, or it cannot it is not collected properly, what happens is that it will promote fire. So because it is flammable. The usual or the conventional design for our gas vents is the use of gabions. So on the slope of our landfill, we need to install gabion. Gabion is just like boulders or rocks where we put in a wire mesh, and then we need to put it on the surface of our sanitary landfill. And because it is composed of rocks or boulders, what happens is that it has voids. And of course, that voids, it allows the flow of your methane gases. It allows the flow of your methane gases. And that gabion will already serve as your gas venting facility. And it will be collected. And what we could do is that instead of using again gabion, why not we could use a combination of our drainage geocomposite and a filled drainage material, or our erosion mat. Our erosion mat it is also the material that is sandwiched in the drainage geocomposite. So it will also serve as our drainage material. So instead of using gabion, why not use a combination of an erosion mat and a drainage geocomposite? We just need to put it on top of it, and then it will already serve as our gas venting facility. What will happen is that again we can lessen the thickness of our system. Instead of using a gabion having a 300 to 500 millimeter thickness, we can just lessen it by using drainage geocomposite and erosion mat. And next for the access roads. Again, access roads, it allows the flow or the traveling of the trucks. And of course, you would like to have a good access roads because it will carry tons and tons of waste every day. So that is why, on the solution of our access roads, actually, it depends on where your sanitary landfill is located. So we do have different solutions on access roads. And of course, basically, since our sanitary landfill is maybe we have constructed it above. Of course, our access road should have a higher elevation compared to your sanitary landfill. Because if you have a higher elevation of your road, what will happen is that if there is a truck that will pass through that road, it just needs to dump all of the waste on your sanitary landfill. That is why on our sanitary landfill, the usual access roads that they are constructing is a road embankment. So on the road embankment, if you would want to steepen the slope, you can just use a reinforced soil slope again, or mechanically stabilized earth wall. And if you would like to construct your access road using asphalt, we could also have an asphalt reinforcement for our fiberglass geogrids. Also, in our embankment, for us to be able to reinforce our soil underneath our embankment, we can put basal reinforcement. If your sanitary landfill is situated in a mountainous area, there's a possibility of rockfall. We could protect our access roads by installing rockfall barriers. We could use drapery systems. We could use soil nailings or rockfall embankments. So there are many solutions. And the last one is the landfill cover. So again, this landfill cover is on the operation side of sanitary landfill. So this landfill cover, this is I have mentioned that every at the end of every operating day of a sanitary landfill, there is a requirement to put a soil cover to cover the whole waste to prevent to have animal control, odor control, erosion control, so to prevent those things. And we do have different landfill cover. We do have daily soil cover, we do have intermediate soil cover, and we do have final soil cover. But I would like to focus on daily soil cover. On the daily soil cover, it is required to have at least 6 inches thick of soil cover or daily soil cover at the end of each workday. So what does this mean? Meaning if I have installed or I have put a waste on the sanitary landfill and I have already finished the operation of the sanitary landfill on that day, after putting the waste, I need to have a 6 inches of soil cover. And then the next day, I will put waste again. And then after that day, I need to put a 6 inches of soil cover. So imagine on a day-to-day basis, you are putting 6 inches of soil cover. So what happens is that it eats up space in your sanitary landfill. That is why what we would like to recommend is that why not, instead of using soil as a covering for your waste, why not use an alternative daily cover? So that is why we would like to introduce another innovation, that is the use of alternative daily cover. But for the discussion of the alternative daily cover, I would like to turn I would like to turn over this presentation to my colleague, Engineer Carlos Xavier Isip, our Technical Business Development Engineer for Erosion Control. Thank you.
Thank you, Engineer Carmela. I'll be continuing this portion of the webinar with a focus on landfill covers. Alright, so landfill covers are generally intended to minimize the impact of the landfill on its surroundings. So specifically, we want to control animals, odor control, dust control, and erosion control. So in the next few slides, we'll be showing the common types of landfill covers. One of the first materials that comes into mind is tarps. Now you also have geotextiles. Now with both tarps and geotextiles, they need to be dragged over the landfill when installing. And oftentimes, these need to be removed when the landfill is ready to accept new solid waste and then placed again at the top at the end of the workday. Now we can also use spray-on covers. So what we do here is we typically mix our base material with water and spray it using a hydroseeding machine on top of the landfill. So this is supposed to harden into a protective shell covering the landfill. Lastly, we have our most common type of daily cover, which is the soil cover. So this is usually soil in the form of clay that is transported onto the landfill using trucks and then compacted on the surface to decrease the permeability of the covering layer. Now, top coat ADC or alternative daily cover is a type of spray-on cover which aims to control odor, disease, vectors, scavenging, and erosion. So because it is a type of spray-on cover, it does not need to be applied at the requirement of 6 inches as opposed to using the soil cover. So by using an ADC, which is applied very thinly, we can save at least 20% of the landfill space and eventually extend the design life of our landfill. So this is what an ADC or top coat looks like. As you can see, it is color dyed to allow for easy spotting, making sure that the operator covers the desired area fully and effectively. So top coat ADC achieves everything that is designed to do because of these key ingredients. So we have cellulose fibers that make up the majority of the ADC. So these cellulose fibers are thermally refined and phytosanitized, forming an eco-friendly and biodegradable matrix. So we also have tackifiers that are composed of blended high viscosity colloidal polysaccharides. Now this makes sure that the ADC adheres strongly to the surface of the landfill, and which will also help us in forming a hard layer. Okay, so when using an ADC, we have three key benefits. So the first is space savings. Second is that it decreases the impermeable layers within the landfill cross-section. And lastly, it is also easy to apply. So first is space savings. So ADCs only need to be sprayed at around 0.64 centimeters per day as opposed to the 15 centimeters when using compacted clay. So because daily cover is applied daily, the space savings accumulate very quickly. Over here, the graph in the right represents the space used by each cover type. So the gray area represents the soil cover, while the green area represents the space used by the ADC. And as you can see, the difference between both areas is quite large. Now this will translate not only into space savings, but also in extending the design of your landfill. So this table shows just how much space savings an ADC gives your landfill in terms of number of days added to the design life of your landfill. So a typical landfill with a 250 tonnage of capacity will add a 180 days to the capacity of the landfill per year of usage when we replace the soil cover with ADC. So second key benefit is that it decreases the number of impermeable layers within your landfill cross-section. So this diagram shows the gas movement in a landfill cross-section. So the number of daily impermeable layers as highlighted in the color red arrow, this impedes the flow of gas, now resulting in less effective gas collection and requiring more extensive structures to boost the flow of methane gas and leachate migration within the system. If we use an ADC that is biodegradable, we are limiting the number of impermeable daily covers. Now, because an ADC is biodegradable, it will not hinder the flow of gas inside the landfill because it degrades alongside the trash. Now, this will result in more efficient and higher quality methane gas collection and leachate management. So the last key benefit is that it is very easy to apply. There's no need to walk over and drag the material over the working phase. There's no need to remove the material for the next day of trash collection. And it also has a dark green color, which makes spotting very easy. And because of its versatility, it can be sprayed by using just 2 operators for the whole operation. So we are actually saving time and money by applying this product. Now, let's look at RA 9003 or the Ecological Solid Waste Management Act of 2000. Specifically, let's look at IRR rule number 14 on the operation of sanitary landfill. So rule 14 states that a daily cover consisting of soil shall be applied at least 6 inches or 15 centimeters thick at the end of each workday. Now it also states that an ADC or alternative daily cover can be used provided that it meets the criteria. Now, the IRR also states that we have to have an additional interim soil cover if your landfill will not be used for a long time, and also the installation of a final cover at the end of the design life of the landfill. Now, I would like to cite a US EPA study that investigates the use of ADC in sanitary landfills. So specifically, this document is EPA 600 SR 93 172. Let's look at this highlighted section over here, spray on ADCs. The conclusions of the study found that ADCs introduce significant cost savings, also improve effectiveness in meeting site operational and regulatory requirements, and also more effective management of leachate and gases. So let's look at ASTM D6523, which is the standard guide for the evaluation and selection of alternative daily bulbers or SLF. Now, this is one of the main guidelines that is considered when selecting an ADC. So here are the parameters that we are looking at. It should not be, there's no need for removal of the ADC in between waste reception. It should be able to withstand moderate to heavy rainfall and resist winds of up to 45 miles per hour or 72 kilometers per hour. It should not interfere with leachate and gas migration while also being able to shed away infiltrating rainwater. Now, aside from ASTM D6523, here is a summary of other performance and environmental properties which an ADC should be able to comply with. Now, with regards to environmental compatibility, I'd like to mention that our ADC top coat also passes the EPA 503 biosolid limits. So this is what the EPA 503 looks like. Here are the environmental parameters, thresholds, that an ADC should be able to comply with. Now, currently, top coat is by the where it has already passed all US government regulations, it's been tested as an alternative agriculture on land. Now, this video is in the Southeast Asia region, where taco is also widespread. So for fast-growing cities often find that they're running out of space for new landfills, and so they need a way to extend the design life of their existing landfills. And top coat ADC, or any type of ADC for that matter, is a great way to achieve that. Alright, that's the end of the webinar. Thank you very much for listening, and we'll be ready for some of your questions after this short break.
puso din.
Wala nilang kapis sa grouping o kung yun ang mga tax. Balik ko sa mga sakit na ba? Isip na po. Ipunta ko ano po. Balik na ako. Marunong ng sa lupi. Yung kopya to sa parang may zoom doon.
Asbang na lang kasi pag-asbang na sa ako. Kaya naibawas yung balik sa ako. Wala ka ulit ng bala na.
Sira mo ba yun? Pero balik ako.
Unsa may sudan ta mo?
Balik. Ma'am, kemana usah di kaum aktual occupant, isa
Mode of acquisition. Aha man na.
aktual
Occupant. Oh.
occupant.
Ana.
Kahit na otro.
Ano man?
Doon na sa mga auditor ko.
Gagamay naman ka.
15 ko na, 50 plus mo na.
Ha? Yan, mukha na kayo ni Adlaw sir. Kaya parang kuwan. Lalo ka sa ato ang point. Hindi ni Princess o kuwan na link. Daily? Oo. Di ba daily na tanong?
Karon, di ko mo din.
Weekly?
Monthly. Kuwada ang pud mo. By monthly.
Daily, pero dapat daily ka ito.
Dili na.
Daily?
Dili na. Dili na tayo yan. Wala na to, ma'am. Null and void na to. Yan siya masya.
Oo.
So, ayun naman, ma'am. Kay kuwan
deadline.
Ang deadline.
Wala na akong TV ha. Wala na akong tanan ayaw akong TV.
7:30 ko mga ako. Alas 7 na may meeting. Nagdala na kaya sa mga gamit. Nag-usa na yung dala ng chinilas. Mga ka-arbanay, sleeper. Katungay. Oh. Dato na to? Ang mo. Wala na. Magbayad ng renta. Nagdala ka 10. Oh. Oh. Dati pagkaon. Okay lang. Maaham naman yung hapon diha na sa tulo. Kaon na lang pinang sa balay. Ipila man may kabok magsakay. Ito, kasi siya nga ito ni. Niya. Niya. Si Choy, wala na nag-duty. Kung sa man ang mga bata, wala na nag-sisigungan. Ganahan siya mag-espiro. So, baguman pa. Tunggu sa pagsulat mo ganyan. Ano yan? Bukan ba rin? Di naman dahil kang kulit na. Bakit? Pila pa sa rin yung ulo. Pila man kita ka-agaw dito, mag-ulit na domingo. Minsan man ang bahay nato sa kaya mo, nang palong nato mo sa bahay. Kailangan. Ang kaling gabigan, asan friends? Okay. Sundo, napunta nila na.
ito. Nalipat mo ba niya?
Dito ay ma. Namin sa diha ah.
Magtapat ko sila yung mga
Ha?
sampag sa mga uy, magtapat sa mga may hindi pang sa mga kung ano na daw ito una na pag ito na nagtapat sa mga sa nakakaisip gusto ko ba gusto ko mo
Ikaw ande. Mana mo lang sa kanya taman.
lagi buwan na uy may bag episode 1 ba?
Ayun pagdalang ilong anak sa Joseph.
Huwag di mo muglaw.
Uy, mapag-ipag-ibig na.
Ako sa prison sa Runday.
Mana? Okay, survey na. How would you rate the webinar?
Kasi
7?
Ay, tatrabaho ni. Sa kuwan eh.
day ako sa prison day.
Oo.
Naman eh.
Wala mo ko'y 10. Oh,
9:40 mo pa. Ako yun ay
la. How would you rate the speaker? Yes, what speaker?
Dahil sa yun ay ayo. Hi Joseph.
Hey, ma'am.
Oh, see. Excuse. Request si Mami. Kasi dito niya nilitaw kung nagpuan sa cubicle.
Day, ato na ko, day.
Ito kayo may mo nga mag-report para sa kuwan. Kung namin, required. Pag-report niya na nabilit ka ng mga pictures na ito. Naman ko siya nagpunod din sa ubos. Nakasa to siya posible na po.
Wala, kasi yun ang sa plano ng mag-report. Ay, siya lang ako.
Kami ba yung buhat? O kami magbuhat? Kanya, mag-pictures, i-support. I-retrieve na lang to sa CCTV. Paghan niya.
Ay, sakto. Ka-birthday mo po eh.
Pero hindi pa na ako makulong kaya napas na rin mo.
Ako, maglakaw na ako. Dagan kayo pa na
Eh, sa alit ko, ano gano'n?
Pero,
Pero,
Si ma'am.
pero yun na. Aw, ang putang. Emang ka.
Sige, direct na.
pero kung naikuan din eh, mo, kung sa tawahan eh, o mo pilit-pilit nga magkuhan siya, mag-playback.
Kuya? Kuya ba ni?
Di ba ito mga ni?
Hindi mo mag-playback ka na, pero kuhan lang isa lang mo, kuhan ka pa lang kuhan ba. Pwede mo lipan sa ilit, nasa ilit. Pag-playback na sa iya, sa tubig.
Asa may pilitan ng payback?
Sige lang, ito doon na ako sa dito. Okay, lapang mo ito doon.
Sa ulit pag-playback set. Yan ang pinag-pindot ra. Spison. Asa ka siya ng dulo mo sa ano?
Nay, ikaw na lang ikaw na i-take.
Magkuha lang ng pizza ba?
Sa lera man eh, ako na lang ikaw na pizza kuya. Pili na lang sa pizza. Pili lang pizza kung ano sa... Yan na lang ang bigay.
Ay, sorry. For some reasons, ma'am.
Unsa daghan ang imong taga-price? Mas madaghan.
Sa makatubag. Chat.
Di ba kaya para makuha na ko kay ako mong segregate ang kuan. Segregate. Ikuan ba ang face mask?
Lahi-lahi, ma'am.
Oo. Ay daghan na pud kaayo isa ka box.
Baod yun. Ay, ma'am, no? Sa katong last na part, ma'am, kay isa-isahon ba yan na ako? Saka adto, katong kani akong gi-prepare nga kuan kani.
So unsa man kadaghan ang face mask ra?
Ako na lang siguro ning ihapon, ma'am, para sure.
So sila ang tagaan.
Di makatama sila.
So mo na mo.
Eh, pagsaba, nagtataguglo.
Sige lang.
Recyclable metal siya.
Sige, ako na ko ni. Sige, para mo niya ako pagani.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Ano ragot ni kanang kuan? Love. Kanya. Kani-kaniya kuan.
Narito, nagpadulong dito.
Pila?
Ma'am. 60 ka bata. So, pila man ang kamas? 50, 50. Pila
Ramay raman?
15 ni ma'am ang suludan niya.
Well, nakay kung 60 ka bata, ang katulong ka face mask.
Pwede na ako.
Ha? Oo.
Tapos katungkuan,
Katong
Notebook.
price. Mora to sa question. Q&A.
kuan ka na.
Punta ito ni Hata.
Oo.
Sige.
Title sa RA 9003,
Yeah.
tapos mag-describe sila sa picture na ako ipakita.
So, ingon na ani, so pakuhaon na lang ako siya. Tapos ko, tulo-tulo.
Ma'am, pakuhaan na natin sila.
Ganun ko.
Kaya bas hindi ay dili makatubag.
Okay,
Mali siya pagbutang ba?
Ah, mao.
I-check mo na yun.
Sige, sige. So, ano na lang.
Call na ta og 10 correct kuan. 10 na to sila. Diday na to kay kuan magugmang bugot. 10 sa niya para makita jud ba kung tama yung pagbuta. Maka-picture pud ta. Sige. Pero na pa sila guide kay katong ato ipanghatag naman dito. Discuss ko na ko. Okay lang na.
Printer and pwede rin siguro kaniraan sila na ano yun, not necessary yung individual yun.
Gali, magdaghan naman na ma'am ay.
Hindi naman siya maganaan.
Nadaot sa ato ang pag-print.
Buhay sa siya.
Ma'am, hiramot sa nato ning kuan ma'am no. Gunting, dalaon na nato niya. Mag-send sa kubi og link kay ang mga LGUs karong hapon ay virtual.